I will use this exercise to give an example of how to calculate the hauling productivity of trucks. We are dealing with a Caterpillar loader and unknown number of trucks. We are given the shown parameters for the loader, trucks, and the whole road. In part A, we need to calculate the number of loader cycles to fill a single truck. We can do that by dividing the effective truck capacity over the loader's effective bucket capacity. The answer is 8.5 cycles, but we will have to round it up to 9 bucket cycles to make sure we have full truckloads. In part B, I will show how to calculate the times in minutes of the main truck steps: loading, hauling, and returning. Load time is the total time needed to load 9 buckets in the truck. The whole time is calculated by dividing the distance over the speed along the different haul road 3 segments. The return time is calculated in the same way. So we can add up these 3 times and the dumping time of 0.5 minutes to get the total truck cycle time. In part C, we will use our knowledge of the truck and loader cycle times to calculate the balance point of their crew or fleet. Our balance point turns out to be 2.1, so we will round it to 3 trucks to cover the loader and make it 100% utilized. In part D, we need to determine the crew size needed to achieve 800 loose cubic yards per hour. We need first to check if the crew we balanced before of 1 loader and 3 trucks will be able to achieve this production rate. As we rounded up our balance point, the crew production will equal the loader production. Big warning here, it will not equal the production of 3 trucks. It will equal the production of 2.1 trucks. This is why one of the trucks will be idle at about 1/3 of the time. The loader production will be the bucket capacity over the bucket cycle time. As you can see, using 1 loader and its balanced number of trucks will not be enough to achieve the target production. So we need to use 1 more loader. 2 loaders are enough, as each is capable of achieving more than half of the target production. We need to rebalance the number of trucks. We will do so by calculating the production of a single truck using the similar concept of cycle output over cycle time. Then figuring out the number of trucks to achieve 800 loose cubic yards per hour, knowing that each one can haul 202 loose cubic yards per hour. We have to round up our answer to 4 trucks. So in summary, we need to use 2 loaders and 4 trucks to move 800 loose cubic yards per hour.